Hello and welcome to my roundup of my prototypes. So, since a while I'm trying to make a water cooling block for a 50-watt LED, and those are my tries. I've gone down two different paths. The one path is cooling the LED just from the backside, and the other path was cooling the LED from the front and the back. But there I ran into some problems. Let me just start with the first prototype and the first idea. The first prototype was simply a 3D printed box with 3D printed fittings with a LED epoxied into the bottom, and so it's a simple back-cooled design. It worked quite good and it still works. The block is a little bit leaky because it's just normal RBS, not smooth, not done anything to it. But still though, this one still works. But it was a little bit chunky, and also I wasn't happy with the 3D printed parts, because if one of those broke, you can throw away the whole thing because the LED is epoxied inside. So that was the first try. Then I kinda got in my head that maybe I could cool the LED also from the front, because there are the drivers and they get hot, so I could submerge the whole LED. And this is what I tried with this prototype. This prototype takes the LED, encases it fully, and we have a little bit of plexiglass here in the front, and the water flows behind the LED and in front of the LED. So you have a millimeter of water between the plexiglass and the LED itself. I ran into multiple problems with this. The first problem was I got isolation issues, and after a time the epoxy got cracks or whatever, and we had current between the live wires. And yeah, that wasn't good. I mean, it still was shining, but lightning in your LED isn't so cool in the water. Also, I got problems with leaks because combining the wires into the 3D printed part with epoxy, it was all pretty crude. It did work for a time, but you can see the screws rusted and this wasn't perfect. The next try I did was with this model. This model was a little bit nicer in design. It had smooth corners. It was well through designed. I could insert a 1/4 inch fittings here and here, and it kind of worked. It was a little bit leaky on the wire entrance point again, but because I coated the whole 3D printed part on the inside with epoxy, it was more tight than the version before. But still, after a while, the electricity, it just ate through the epoxy that was supposed to isolate the whole thing, and I got shorts again. So this one, it looked very nice, kinda like a submarine. And I'm kind of proud to have designed this whole shell and the front plate of it. I don't have the front plate anymore, but there was a front plate with a custom-made silicon seal and plexiglass, but it broke under pressure. So in the end, this wasn't also not very good, but it worked for a while, and I have to say I had fun making it, because I learned a lot of things about OpenSCAD and making 3D prints and designs like this. So since this didn't work, I got back to this idea, just cooling it from the bottom. So I was thinking, what can I do? How can I get this thing tight if I just cool it from the bottom? And the idea then was, I could just use an O-ring. So I took an O-ring and made it and made a 3D printed part like this, where the O-ring would fit in, and then you have the LED, and you screw it down from so the O-ring makes contact with the bottom side of the LED, and you have a seal. So this was an idea that was very small. I liked that about it. But then I ran into problems because I had to get this thing tight, and I tried multiple things. I tried Plasti-Dip, I tried I tried nail polish. In the end, the thing that worked were epoxy again. This prototype ran for about 2 weeks, and it was sealed with epoxy on the inside, but after taking it out today I found out the epoxy isn't connected anymore to the inside of the 3D print. It's just a layer, it's not connected in the inside anymore. So I expect this thing would fail if I let it run for any longer. But it had, for the first time, really nice fittings on it. But on the topics of fittings I will say a little bit more later. The next stage where okay, I realized 3D prints maybe not the perfect solution for making this thing watertight. So my options were getting CNC to cut the parts from acrylic, or to use resin and to make my own parts. So I did this. I got some forming silicone and made a print that I could mold. So I made a mold with it, removed it, and then I poured in epoxy. And then what I get is this type of part. It looks really nice, it feels really nice, and I can just pop an O-ring in there and it should be tight, right? Because remember, it's basically the same. This one was tight too. But here comes the difference. I tried it out, and what I found out was that even when the resin is fully cured, it's still not as stiff as PLA 3D prints. So I got a lot of warping on the sides and it started leaking. So this wasn't perfect. But in this I, for the first time, used new fittings, because the old fittings were standard water cooling fittings. I wanted to use them because everyone is familiar with them and you can get them everywhere. But the thing is, since it's supposed for be fittings for cool RGB water cooled gaming rigs, it's overpriced AF. So one fitting of this costs me like €7, and that's too much. So I had to look for other things, and first I tried those, but those were shit. And then I tried pneumatic quick connectors, and they work really fine. I don't need any hose clamps or something like that. It just plugs in, plugs out, and it's very nice to use. The downside is I only have 6 millimeters inner diameter in the tubes, but it seems to work fine. I have enough water flow for this to work. So yeah, so I stayed with this fittings for the next prototype. That's the newest to this point right now. And this prototype is basically a 50 watt LED completely encased in epoxy. You have on the inside a hollow cavity where the bottom, the cooling side, the back side of the LED is in connection with the water when it flows through there. And again, I have the quick connection fittings. Also, the difference now is the fittings are moved to the side, so you can just mount this directly to the ceiling without having to use a 90-degree bonus round. For anyone who cares, how did I create a hollow spot inside a molded part? Well, I cheated a little bit because it wasn't I didn't mold the whole thing at once. At first I just molded the bottom side. So I put an LED inside here, and yeah, molded the downside, so I had left a cavity in the middle, a little bit like this, and then I just flipped the whole thing into this tray and molded the top onto it. So it's a two-step process that takes a while because the resin takes almost 2 days to cure, so to make one of those at the time I would need 4 days.